Alright, problem number 2a. We want to take this Cartesian point, x comma y, and we want to turn it into a polar point, r comma theta. And in order to do so, we need to use the relationships that we came up with on part 1. So we need to find r, and so to do so, we will use our relationship r squared equals x squared plus y squared, which came from the Pythagorean theorem. And then we will use the relationship theta equals tan inverse of y over x. So let's see what we can do. Let's find r first. We will have r squared equals the quantity, negative 3 squared, plus the quantity, the negative square root of 27 squared, equals r squared. So let's square those pieces. Negative 3 squared is positive 9. Plus, if you're squaring a square root, you are essentially undoing the square root operation, which means we will get our 27. And notice that it is a positive 27 because we're taking a negative number and squaring it. So yes, it will be positive. So r squared equals 9 plus 27, which is 36. And so if we square root both sides, r equals 6. And now we need to find a theta. So we need to say that the tan inverse of y over x, so negative square root of 27 over negative 3, that will equal our theta, again from what we came up with in the first problem. But how do I do that without a calculator? Well, let's simplify things. First off, they're both negative, so those negatives are going to go away, so let's just pretend like they're both positive. Not going to affect us right now. But what can we do with that square root of 27? Well, recognize that the square root of 27 is 9 times 3. The square root of 9 times 3 is the same as the square root of 9 times the square root of 3, and the square root of the square root of 9 is 3, so this is going to simplify down to just 3 root 3. Square root of 27 is equivalent to 3 root 3. So really what we have is the inverse tangent of 3 root 3 over 3, and boom, those 3's cancel. So really, it's just the arctan of the square root of 3. Now this is asking us a question. This is saying on the unit circle, which angle line gives us a slope of the square root of 3? And I've explained this a bunch in class. We've gone over it a whole bunch. But real quickly, I know that it's either this line at pi over 3 or this line at pi over 6. Those are the only real interesting tangent values we get, or rather the less easy to find tangent values. Of those two, I remember one is the square root of 3, and the other is the square root of 3 over 3. And we can remember that tangent is slope. And so the bigger of the two numbers, root 3 versus root 3 over 3, well, root 3 is the bigger number, and this is the line that has the steeper slope. And so that helped me remember that the square root of 3 is the tangent value at pi over 3. Alright, I had to just come inside because some dude started doing a leaf blower and it got really loud. But now I'm in an office. I'm in my dad's office and there is a clock ticking. So if you can hear that and it's annoying, sorry, can't really help you there. But anyways, we were talking about how we can evaluate this expression, tan inverse of the square root of 3. How do we know what that is without a calculator? So we've identified that it is along this pi over 3 line, but there are actually two angles that correspond to this same tangent value right here. Pi over 3 at the top and 4 pi over 3 down there, right? Because we're talking about they are the same line, tangent is slope. So it's one of those two. How do we know which one? Well, we need to look back at the original point. Notice that the original point, x is negative and y is negative, which means I am down here in this third quadrant, which means my angle has to be 4 pi over 3. So if I put that all together, I get my polar point, radius of 6, angle of 4 pi over 3.